Assalamu alaikum. I am Munira. First of all, let me thank you all for supported last presentation. You did act as a catalyst for me. My presentation title today is Synthesis and Characterization of Copper-doped titanium dioxide nanoparticles for DSSC and photocatalytic applications. Let's move to the first part of my talk, which is about abstract. Take a look at this graphical abstract. Copper-doped titanium dioxide nanoparticles were synthesized by Sol-Gel technique with different molar concentration of copper. The effect of copper doping on the structural, morphological, compositional, optical, and electrical properties of titanium dioxide was systematically analyzed for its better suitability as photoanode in dye sensitized solar cell and photocatalyst in dye degradation. The maximum efficiency of DSSC is 3.9%. The maximum efficiency of DSSC is 3.9%, and the maximum degradation of rhodamine B dye is 97%. The energy requirements had led to the widest challenges of non-pollutant energy resources. Solar energy is the best. In solar cell, the photon is converted into electron, and the conversion efficiency must be high. Dye sensitized solar cell is third generation solar cell having high performance and working in low light visible conditions compared to other generation solar cell. The semiconducting metal oxide nanomaterial as titanium dioxide, zinc oxide, or others. Titanium dioxide is material for various applications. It's non-toxic, good optical, and show high stability in DSSC and photocatalyst application. Researchers have applied various strategies to shift the titanium dioxide absorption towards the visible region. The doping of different transition metal, nickel, copper, or sulfur shifts the titanium dioxide absorption toward the visible region. The optimized copper concentration of 0.1 copper-doped titanium dioxide has higher efficiency of dye sensitized solar cell 3.9% and photocatalytic applications as well 97%. The experimental techniques divided into two parts. Synthesis of copper-doped titanium dioxide nanoparticles by Sol-Gel technique and fabrication of dye-sensitized solar cell. As we can see from figure 1, preparation mixture solution by two mixtures. The first mixture is titanium tetraisopropoxide and isopropyl alcohol that stirred for 1 hour. After that, add a glacial acetic acid and di-ionized water. The second mixture prepared by stirred for 1 hour. The copper nitrate hexahydrate isopropyl alcohol. Continuously stirred up to gel formation at 70 Celsius degree, gel formation annealed at 300 Celsius degree for 3 hours. Copper-doped titanium dioxide nanoparticles act as photocatalyst and act as photoanode in DSSC. Accordingly, we complete the rest of the preparations. Photocatalytic activity, the degradation percent pseudo first order kinetic and half-life time for the rhodamine B dye are calculating by following equation. Figure 2 shows the XRD pattern of copper doped titanium dioxide nanoparticles that absorbed 101, 004, 200, 105, 211, 204, 116, 220, and 215 plants of the samples, which will withstand of innate titanium dioxide with tetragonal crystal system. The absence of impurity peaks in the diffraction pattern of CT1 to CT3 indicates the occupancy of copper ions to the mine sits of the titanium dioxide lattice. Two additional 111 and 200 plane in the sample CT4 indicate the formation of copper oxide, maybe due to the higher concentration of copper. Crystalline size for CT3 is the smallest. To analysis morphology and compositional using scan electron microscope and trans electron microscope. It's clearly from these figures a greater number of secondary particles are aggregated to form agglomerations. Trans-electron microscope for the sample CT3 nanoparticles are spherical shape with some porous and agglomerated. We can understand from this figure no other impurities with percentage except titanium, oxygen, and copper. Ultraviolet diffused reflectance spectroscopic measurements, the UV spectra of copper doped titanium dioxide nanoparticles are shown in this figure. The reflectance of the sample decreases with increasing the copper concentration, which shifts the adsorption in the visible region. It's noted that the emission peak absorbed at 380, 469, and 535 nanometer corresponds to the band BL emission, free exciting, and oxygen vacancies. The BL intensities are very impressionable to metal ion doping. When copper is doped into titanium dioxide, the intensity of the BL emission is reduced compared to that of undoped titanium dioxide. We can calculate photoconversion efficiency from GFE characterization, and from GFE the obtained DSSC efficiencies were found to be 3.9% for sample CT3. From this, we can see the sample CT3 is the least impedance. Under visible light irradiation, the photocatalysis from CT0 to CT4 in rhodamine B dye solution are equilibrated with equal intervals of time up to 116 minutes, except for the sample CT3 120 minutes. The present work focused on the training of physical properties of titanium dioxide by copper doping by sol-gel technique for DSSC and photocatalytic applications. XRT study, the average crystallic size of doped titanium dioxide was found to be 8 nanometer, which was less than that of undoped titanium dioxide 10 nanometer. Scan electron microscope and truss electron microscope analysis shows the spherical shape morphology. EDS analysis confirms the presence of titanium, oxygen, and copper. The lower PL emission intensity was observed for CT3 sample. From GV characteristic, the obtained DSSC efficiencies were found to be 3.9%. The obtained efficiencies of DSS supported with the electrical impedance measurement value. The CT3 sample shows higher rhodamine B dye degradation efficiencies of 97%. From this observation, it was calculated that 0.1 concentration of copper CT3 was the optimum dopant concentration as dopant for titanium dioxide, which was suitable for dye sensitized solar cell and photocatalytic applications.